Good morning. It's March 13th, and this is your daily brief in science. Here's everything you need to know. NASA's Artemis 2 remains on track for an April launch from Cape Canaveral, aiming for a 10-day mission that will loop through Earth orbit, translunar trajectory, a lunar flyby, and return to Earth. A helium flow issue in the Space Launch System upper stage triggered a rollback to the vehicle assembly building for repairs, including seal replacement and battery testing, before rolling back toward the launch pad. If needed, about 4 launch opportunities are anticipated within a 6-day window, depending on hardware readiness and technical constraints. Honeycutt cautioned that early missions carried different risk profiles and warned against over-reliance on probabilistic numbers, while noting efforts to understand and mitigate risk. NASA officials emphasized rigorous risk assessment and mitigation to understand potential failure modes and maximize mission success. Ground teams completed repairs in the VAB and prepared the vehicle for transport to Launch Complex 39B, with safety and risk mitigation highlighted during flight readiness review discussions. Astronaut safety remains the guiding priority, with officials acknowledging inherent unknown risks and describing the mission's risk level as just above a coin toss for perfect execution. The article provides historical context on flight directors and underscores vigilance and decisive leadership as enduring factors in mission success. Current risk discussions contrast with some shuttle-era FRRs, reflecting a generally smoother consensus-driven process for Artemis 2. After a 2-day flight readiness review, NASA stated all teams were cleared to launch, while acknowledging the risks inherent in a test flight. NASA described Artemis 2 as a test flight with inherent risks, noting the hardware and team are prepared, and the FRR evaluated the readiness of the SLS, Orion, and ground systems, with crews joining virtually to review risk posture and mitigation. 2 co-lead authors argue that non-pharmacologic interventions, especially structured home-based exercise, are safe, accessible, and cost-effective options to help preserve cognitive function and daily functioning during chemotherapy. They urge integrating a structured, home-based exercise program into routine chemotherapy care, with monitoring of cognitive and fatigue symptoms and referrals to exercise oncology specialists when needed. The study enrolled 687 patients from 20 community oncology practices across the United States between 2009 and 2014, with most participants being women, many having breast cancer, and all without distant metastases. Participants generally were undergoing their first chemotherapy course and were part of the URCCNCORP research base, with the sample skewing toward breast cancer patients. The EXCAP program combined individually tailored walking and resistance band exercises with daily activity tracking and teach-back instruction, with participants logging steps and resistance training time in diaries. In 2-week cycles, the EXCAP program maintained walking activity and was designed to be safe, accessible, and feasible at home, leveraging pedometer-based tracking and daily diaries. Participants on 2-week chemotherapy cycles who followed EXCAP showed less overall cognitive decline, lower perceived cognitive impairment, and reduced mental fatigue compared with standard care. The full study, titled Effects of Exercise on Cognitive Impairment in Patients Receiving Chemotherapy, a Multi-Center Phase 3 randomized controlled trial, appears in the March 2026 issue of JNCCN, with NCCN resources for patients and caregivers. Independent oncologist commentary notes the findings support NCCN survivorship guidelines that advocate routine physical activity to manage cancer-related cognitive impairment and help maintain independence and quality of life during treatment. Experts not involved in the study likewise endorse the results, reinforcing the idea that preserving cognitive function is crucial for work, independence, and daily life during chemotherapy. A new study from CNIO shows brain immune cells, microglia, influence puberty and fertility by directly talking to GnRH neurons through the RANK protein, revealing a non-neuronal control of reproductive timing. The findings place microglia as regulators of the hypothalamic pituitary gonadal axis by signaling via RANK to modulate GnRH neuron activity. Published in SCIENCE and led by Eva Gonzalez Suarez, The work highlights a direct link between immune cells in the brain and endocrine control, suggesting new paths for therapies. Background context includes the team's interdisciplinary approach, combining neuroscience, endocrinology, and immunology, with human genetic data from congenital hypogonadotropic hypogonadism patients to identify RANK mutations. The study integrated animal models and human genetics, identifying RANK as a candidate gene for diagnosis and a potential therapeutic target in reproductive disorders. CNIO emphasizes its role as Spain's largest cancer research center and notes funding from the European Research Council, La Caixa Foundation, the Community of Madrid, and Spain's Ministry of Science, Innovation and Universities, among others. The research team also receives support from regional programs and state research initiatives, underscoring broad collaboration across Spain, France, and Switzerland. In humans, RANK mutations have been found in patients with congenital hypogonadotropic hypogonadism, linking RANK signaling to fertility disorders and pointing to diagnostic and treatment opportunities. The SCIENCE paper identifies microglial RANK signaling as a mechanism affecting GnRH neuron activity, offering a non-neuronal pathway to regulate puberty and fertility. Identified collaborators include first author Alejandro Collado, with contributions from Noja Borgini, Jing Zhai, Manuel Tena Sempere, and Nelly Pitalud, reflecting a diverse international effort. A new light-driven method from a Cambridge University team uses a metal-free approach to late-stage drug modification, activated by ambient LED light. This visible light-driven process works at room temperature and avoids toxic heavy metal catalysts while forming carbon-carbon bonds through a self-sustaining photo-initiated chain. It enables precise tweaks to complex drug molecules late in development, rather than rebuilding them from scratch. The researchers emphasize sustainability and greener production, aligning with energy transition goals in pharma. The study, published in Nature Synthesis on March 12, 2026, is led by David Vahi and Erwin Reisner, with the DOI 10.38/S44160-026-00994-W. AstraZeneca collaborated to test industrial practicality, demonstrating the method across diverse drug-like molecules and exploring adaptation to continuous flow systems. The collaboration evaluated real-world applicability and scalability across large-scale development scenarios. Contributors include David M. Vahi of St. John's College, Cambridge, and Erwin Reisner, with Trinity College Dublin contributing AI models to predict reaction sites. AI-assisted analysis and machine learning models helped forecast where the reaction would occur on new molecules, speeding candidate identification and reducing trial and error in discovery. The method offers high functional group tolerance and can adapt to continuous flow setups, with potential to reduce waste, energy use, and development time in pharmaceutical manufacturing. Overall, the work highlights sustainable chemistry options in drug synthesis and aligns with broader environmental goals for the industry. A shift is underway in chronic pain care, moving toward personalized, holistic treatment that centers on the mind-body connection and daily function. New approaches emphasize emotional well-being and social factors as much as the physical condition, with technologies like neurostimulation, virtual reality, and artificial intelligence playing integrated roles. This patient-centered model treats the whole person, not just the disease, drawing on emerging tools to fit individual needs. Neurostimulation is currently a low-risk, FDA-regulated therapy with growing evidence, delivered through supervised programs and increasingly accessible for at-home use under professional guidance. It works by delivering a gentle electric current via a headband to modulate brain pathways, offering a non-invasive, drug-free option that can be used at home when properly supervised. Compared with surgeries or medications, neurostimulation avoids invasive procedures and is generally well tolerated, with mild, transient sensations and greater convenience through home use. Chronic pain, defined as lasting 3 months or longer or recurring, often ties to conditions unlikely to fully resolve, and professional guidance helps determine individual management. Conditions like arthritis may be linked to chronic pain, underscoring the need for tailored strategies. The MJHS Institute for Innovation and partners are researching neurostimulation to understand mechanisms and improve accessibility, including home-based options that fit daily life. Chronic pain can affect mood, energy, and daily activities, and is sometimes associated with grief, with emphasis on staying engaged in meaningful life despite pain. A core theme is embedding emotional and social factors into pain management, expanding at-home treatment options, and exploring how new technologies can support patient-centered care. Over the next 5 years, health systems are expected to integrate these tools into personalized care, tailoring support, and ensuring effective implementation. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.